Did you know why Git has become an essential skill for every developer, programmer, or even a graphic designer? Perhaps you heard people say everyone should learn to code, but nowadays more and more people are saying everyone should learn Git. Welcome to Git Complete Training with GitHub. This course is a step-by-step approach to the modern workflow in Git from zero to mastery. Git is the most popular open source version control system in the world. It is used by tech giants like Google, Microsoft, Apple, Facebook, LinkedIn, and much more. Git simplifies the process of working with other developers as you collaborate on projects in the office or remotely. Learning Git is indeed a great addition to your skill set. By the end of this course, you will not only know the ins and outs of Git, but you will also learn how to publish your project. This course includes quizzes and a challenge to aid your learning process. You will also receive a certificate of completion to show your new skill to potential employers. So, without much ado, let's get cracking. Before we begin exploring what Git is all about, it's crucial we first understand what is the term version control. Put simply, Git is a software that keeps track of changes that you make to files and directories. Let's imagine you have a version 1 of a document. You make some changes, now you have version 2. You make some more changes, and now you have version 3. What Git does is that it keeps track of all these different versions for you, and this enables you to move back and forth between the versions and compare the different versions to see exactly what changes. So, Git is known as a version control system, or sometimes referred to as source code management tool. There are other version control systems that predate Git, such as Source Code Control System or SCCS, which was released in 1972 and was developed by AT&T, and it comes with Unix operating system. We have ROCS, which stands for Revision Control System, and it has better performance than SCCS. It was released in 1982. It is open source and cross-platform. We also have CVS, or Concurrent Version System, released in 1986, and it was open source. Also, CVS is much better than ROCS and SCCS because it allows you to work with more than one file at a time. And finally, we had Apache Subversion, SVN, which was released in 2000, and it is the most popular version control system for a very long time. However, there is another version that came out in 2002 known as BitKeeper SCM. It was a closed source, proprietary distributed version control system. BitKeeper has both paid and community version that they gave out for free. From 2002 to 2005, the Linux kernel began using BitKeeper SCM, but it was controversial to use proprietary SCM for Linux kernel because Linux kernel was an open source project. As a matter of fact, in April 2005, the community version stopped being free. As a result of this, Git is a distributed version control. We will talk more about this in the next lecture. Git is an open source project and free software. That means you can download it and use it for free. And because it's open source, community can view the source code and contribute to it. It's also compatible with major operating systems such as Windows, Linux, and Mac OS. So, as people began to discover the great features of Git, Git became the most powerful and popular version control system in the world. Welcome to Distributed Version Control and why it is an essential feature of Git. In the previous movie, we talked about the history of version control systems such as SCCS, ROSC, CVS, and SVN. All four of these use what is known as centralized version control system. This means that one central place is used to store the master copy of your code. The central place or server could be local or remote, and every developer can update their work with the data present in the repository, or can make a commit changes to the data in the repository. Even though this may seem convenient to maintain a single repository, it has some drawbacks. So, Git does not work this way. Git is a distributed version control. The distributed version control model do not necessarily rely on central server to store all of the versions of a project. Different users or contributors each maintain their own repositories instead of working from a central repository. They can commit and update their local repository without any interference. They update their repositories from the central server by an operation called pull, and then effect changes to the main repository by an operation called push, all from the local repository. So, there is no single master repository. It's just a working copies, each with their own change sets. And changes are stored as sets or patches for tracking. Though, by convention, we often designate a repository as being the master repository, but it's not really the architecture of Git. Master repository is just a convention because sometimes every user may be required to submit their changes to a given repository, being the master. Now, all repositories are equal by Git. Git is distributed. As a distributed version control system, it has some couple of advantages. It means that there is no need to rely or communicate with a central server. It also means that we don't need network access in order to effect changes, and as well, no single point of failure in terms of losing an entire data of a project. But in centralized version control model like CVS and SVN, if something goes wrong with that central repository, it can result to data loss for everyone. As a distributed version control model, committing new change set can be done locally without manipulating the data on the main repository. Once you have some couple of change sets ready, you can push them all at once. It also encourages participation and forking of projects. So, the distributed version control is really an important part of the Git architecture. In this lecture, we are going to learn how to install Git on our operating system. If you're using a recent Mac computer, Apple may have pre-installed a version of Git for you. Even if you have that, we can install our own latest version. To obtain a copy of Git, we need to head over to git-scm.com. And here you can see all other information about the Git software. But you also see right down here, it says latest source release, download for Windows. So it automatically detects which operating system I'm working on. So if I click on it, the download page window will come up and it will start downloading automatically. Then I'm asked to save file. Once the download is completed, we can go ahead and click on it or go directly to your download folder. This will open up the installer. Then You can click on the next button to accept the license. You can leave your installation directory by default and click next. Next. Next again. And here you can choose your preferred editor, though this can be changed later. Next, I'm going to choose path. It says, do you want to use Git from Git Bash only, or Git from the command line and third-party software, or use Git optional Unix tools from the command line prompt? So I'm just going to go with the default. Next, it says what kind of secure transport layer you want to use. So I will accept the default there. Next, I'm going to go ahead, accept the default Windows style before it commits them to Linux. And it gives you another choice to either use the Minty Terminal emulator or Windows default console. If you are using Windows 10, you may want to use the default one. But if you're using something older, then you can try out using Minty. So, click next and then install. And the main installation will begin. Once the installation is finished, we can choose if we want to launch Git Bash or view release notes. You can uncheck these boxes and hit on finish. Now, we are done installing Git on our machine. Just to verify if everything is working correctly, I'll fire up the console on Windows or terminal on a Mac and type git space -- version. It should tell you have Git installed. Welcome to the command line. The command line, also known as CLI, terminal or shell, is a place of mystery for many. However, you only need some of the basic commands to start feeling comfortable. Although there are Git graphical user interface software for Windows and Mac OS that could make things a lot easier, but starting and executing Git commands through the command line will make you get a deeper understanding of how Git works. So, it's highly recommended we start from the command line before moving to apps that could make our life more easier. Now, let's get started. If you're on Mac, you're going to be using terminal, and I'm going to be using Git Bash on Windows. Irrespective of the operating system you are on, Git is Git. Most of the command I will be using on Windows can also be executable on Mac. So on Windows, I will simply go to Start menu or search bar. Okay, now I'm going to pin Git Bash to taskbar so I don't keep searching for it next time. Alright, as the name already implies, the command line is used to execute command. You type something to it and confirm the command by hitting enter. It is important to note that these commands that you type are dependent on your current location. The current location is simply your current directory or path on your computer. So, let's issue our first command to find out where we currently are. Type pwd. Now click enter. As you can see, it says I am on C, users, shock Jesus, and that is going to be different for you. pwd stands for print working directory. It simply returns the path to a local folder on your computer's disk. If I want to change my current working directory by going back, I will type cd, where cd stands for change directory, Then if I want to move one directory upward, that is into the current folder's parent folder, I will enter space dot dot. Now print working directory again. Often you will see a special kind of path. This sign stands for your user account home folder. That means you may want to use a shorthand form of this. Now, let's go ahead and jump back into our directory subfolder by typing cd space, and in my case, it's Shock Jesus. Let's visualize this by typing pwd again. And here you can see how we can access subfolders. Now let's navigate to our desktop. Print working directory again. Great. Now let's create a new folder or directory on our desktop. To make a directory is universal to both Windows and Mac OS. To make a directory, simply type mkdir space, the directory name, and I'm going to be naming it as my project. You notice that as soon as I click enter, the directory was created on my desktop. Also, when creating a directory, be sure not to include special characters. Now that we have created our own directory, we need to navigate or change to it. Type cd space, the directory name. To see what's inside a directory, you're going to type ls. And here you can see that no file exists. The ls command is used to list the file content of a directory. Now let's go ahead and create a new file inside of it. This is where it's going to get a little different for Windows and Mac users. Now, for Mac users, there are a couple of ways to do this. If you have Nano Editor, then you can simply type nano space and the name of your file which you want to create. Then you'll be prompted to enter some text. After that, hold Ctrl S and then type Y for yes to save. Now, back to Windows users. To make things simple, type Notepad space, the name of your file. In my case, I'm going to be naming it example.txt. If I hit enter, I'll be prompted to create a new file because it does not exist. So I will enter some text, then save and close. Just to verify that it's there, simply type ls. And here we have it. Also, if I want to check this inside a directory, great, here we have it. Next, if I want to delete or remove a file, we're going to be typing @m space and the name of the file we want to remove. In our case, let's remove our newly created example.txt file. Now let's type ls to verify that it's not there anymore. So, now that we've covered some of the most useful commands of the command line, let's get started using Git.